B&W were pioneers in so-called woven fibre cones, and the best material for this is Kevlar. Now Kevlar has good internal damping, and it allows just the right amount of resin to be added, so it makes it not totally stiff. Metal cones and cones with too much resin are very stiff, and consequently they ring like bells. Kevlar allows just the right kind of controlled breakup to occur. Now controlled breakup allows a central radiating area to smoothly reduce in size at just the right rate, and it also allows the outer regions to smoothly cancel out as you go to higher and higher frequencies. This is a consequence of so-called fourfold symmetry. Now on this demonstration we see an impulse being fed into the voice coil of a plastic cone, and we see a fast impulse moving to the surround, followed by slower impulses which get reflected from the surround, just like a sea wave being reflected off a sea wall. Now every time you can get a whole number of half wavelengths of the sound fitting in between the voice coil and the chassis, we get what is known as a standing wave, otherwise known as a resonance occurring, which gives a peak and a dip in the response. And because plastic cones are totally symmetrical all the way round, there's no possibility of cancellation, and the resulting resonances are highly audible. Now let's have a look at the way Kevlar behaves in comparison. What we see here is an impulse going into a Kevlar cone, and the first few frames of this show that the wave speed is different in different directions. In fact, I'll need my hands to explain this. With a Kevlar cone you've got woven fibres which are warp, weft and bias directions, and it's actually stiffer in the bias direction. And if you've got just the right amount of resin in, it's exactly the right amount of increased stiffness in the bias direction, which allows the resonances in that direction to cancel out the resonances in the other direction.